Everyone, welcome to our lesson on parts of circles. And as you can see, I've got my favorite circles here in fresh pack, family size, double stuffs. And these will be very handy. I also have my glass of milk here. And just in case, some of these break, I'm ready. I'm ready to consume them. So first is a word I'm sure you already know, and that is circumference. Latin for carry it all the way around. All the way around. So this would be our circumference, a little bit lumpy there. And notice I have this under the whole. And we have a way to calculate this. The formula for this is either diameter pi, or in more advanced classes, advanced math classes, you see them divided like 2 pi times the radius, 2 pi r. So either way, you double the radius or you just use the diameter to find a way around that. Area of a circle, of course, is not the measure on the outside, but the measure on the inside. We have all of this, and even though this is not a square, this would be measured in square inches, square millimeters, square centimeters. This also has a formula that we've seen a lot of recently, and that is pi r squared. So these two look similar, but this is a 2 times pi r, and then this is pi times r again, or r squared. Now let's take a look at what happens when you cut. What happens when you cut part of the circle? And I have tried actually cutting the brown cookie part, and it really does not work. So what if I cut this, and I already messed it up a little bit. I'm trying to do it right down the middle. A quarter. And for argument's sake, let's say that the radius here is 1 inch. 1 squared times pi. This would be a pi, or about 3.14 square inches of cookie Oreo cream. But what if I had a couple friends over and I was like, look, I'm feeling generous. I'm going to give you this much of the circle. Well, it's not half, is it? You can tell that that's a quarter. A quarter, right? So if this whole thing is 1 times pi, this would be 1/4 times pi. Would you agree? And I think I'm going to have to get rid of that. So good. And that's the basic idea here. Before I come over here and write the parts, though, we're going to talk about what just happened here with the knife. This, and 90 degrees is simple. Let's make this a little more interesting. We'll make this like 120 degrees. Okay, and then I will trace this and write out that angle. Okay, so I've traced it, I've cut it. Let's say it's a little more than 120, so maybe we'll say it's 135 degrees. Well, this is going to be how we take parts. So cut it with, not a knife, though this was very effective in cutting the Oreo cream, but we're going to cut it with a central angle. And sure enough, this is the center, and so we call this a central angle. Right there in the middle of the circle. When we cut our circle with a central angle, we are going to get a fraction of the circle. So over here, part or a fraction of what we had on the left. Well, what happens when you cut a piece of the circumference? You get an arc. So here I've done the circumference again, but I really just want this part, and I'm going to make it thick so you can see it. This part of the circle is called arc. So that is a fraction of the circumference. We're not going to talk about arcs too much this week, though there is one or two problems in your assignment that uses it, so I wanted to bring it up. But mostly we're going to talk about this, not the whole area of the circle. You don't get all the Oreo filling. You just get to have this fraction. 135 degrees is a certain fraction of a circle. You may need to do a little calculating with that. Okay, so I've traced another circle here. I realize over here I forgot to put in my central angle, so I'll go back to the arc. How did we know how long the arc was? The central angle cut it for us. So that central angle of 135 degrees is going to cut a certain fraction of the circumference. So this is going to be a fraction of the circumference. And what fraction? Well, what is a whole circle? 360 degrees. And then 135 degrees of it. And now what about over here? We're going to put in the same cutter, same central angle, 135 degrees. But now we're talking about area. You know, what somebody ate here. The missing area here, or often in our problems they'll say the shaded in area. Well, this is also a fraction, but it's not a fraction of circumference, it's a fraction of the area. And that's about it. That's, this lesson is not too complicated, but you can see that we are going to be working with fractions. So it might be good to remind ourselves what little handy tricks we have on the calculator here. If we took 135 and divided it by 36, of course, oh, there's a lot of glare there, sorry, just like in the classroom. We could do some math here and simplify this by hand. It looks like you could divide both of these by 5 at least, right? But we do have this handy trick on the calculator, and I suggest using it for your assignment. And that is, once you get this, I think you have to hit enter to get an answer. You might recognize that. That's actually a pretty common fraction. But in case you don't recognize that as a fraction, we have this old trick, math, enter, enter. Well, I'm realizing you might not have a calculator that does math, enter, enter. Well, if you can find an online calculator that just Google calculator convert fractions, convert decimal to fractions, you probably have a function just like this online. And sure enough, it's 3/8. So let me do one sample problem on this little notes page here. I mean, you could just take a screenshot of this. I suppose I could scan this document. We've got the circumference, the area of a circle, this little piece of the fraction of the circumference is called arc, and I didn't name this. What is this called? This is called the sector. So this week I would like to teach you how to calculate the area of a sector of any circle that you've been given. So let's say that they tell us that this radius is, well, I don't know, let's take that one. Let's say maybe that's 3 centimeters, a 3 centimeter radius. Once you're given the radius and this fraction, you will be able to calculate the area of that circle. So how much of this is gone? A fraction of pi r squared. So first we find out the whole. This is really how this works. Area of a sector will equal the fraction times the whole area. So I think I just mentioned this is 3, so 3 squared. We do pi r squared. We get the whole area as 9 pi. That's pi, that's r squared. As soon as this turns into something that's not a letter, we put it in front. If it's a letter, we put it in back. See that? And then over here, same thing. See the letter, we put the letter in back there. Okay, and what is the fraction? Well, it is 135 over 360. Now, I did that quick simplification to 3/8, but yeah, we could still do this. We're going to multiply, and this is really over 1, right? So the numerators get multiplied. Get this ginormous fraction here, but of course this is going to simplify quite a bit. We would just like to factor out as much as we can. You may remember that 36 is 4 times 9, so we can definitely get rid of a 9 if we divide both sides, top and bottom, that is, by 9, and the 9 goes away, and you get 135 times pi 40. And then you can just keep simplifying. Well, let's see, that's not a multiple of 10, but I could take out a 5. So I take out a 5, let's see, that's 20 plus 7 more, so that's 27. I just divide that by 5, divide this by 5, and I'm sorry, I just started thinking, what's the next step? That doesn't simplify anymore. This is 3 times 3 times 3 over pi. This is 2 times 2 times 2. There's no common factors there. Now, the shorter way is to actually know that that's 3/8. 3/8 times 9 is 27 pi. But did we really need to simplify to 3/8? No, it's just a little bit of a shortcut. Now, if you see a multiple choice and you weren't able to take 135 divided by 40, you didn't know if it equaled 27/8, what could you do? You could just leave the pi there. We're not actually multiplying by 3.14 or anything. We're just leaving pi as pi. That's how we call these exact answers. We leave pi as pi. Don't touch it. And don't forget about it. The answer is not 27 divided by 8. It's 27 times pi divided by 8. But we are going to leave pi as pi. And that's the exact answer. As soon as we multiply by 3.14, it's an approximation. Okay, I'm running out of time, so let me just do this quickly. What is 135 divided by 40? So you could just kind of keep track of that decimal. And then if you're looking through multiple choice, like, oh, well, I need a fraction that equals 3.375. Let me check to see if 27/8 works. You do 27 divided by 8, and sure enough, that's the same thing. So I will make another video with a few examples, and then good luck on the assignment. I'm going to go eat this.